Do you know what SQL injection attacks are? They are a significant threat to web application security. SQL injection attacks are a type of security exploit where an attacker inserts malicious SQL code into a query. This can lead to unauthorized access, data theft, and potentially serious damage to an organization. Picture a lock on a door, but the key is a line of code, and a skilled attacker can craft this key to gain entry. This is not some theoretical danger. It's a real-world threat that exploits vulnerabilities in a web application's database query software. It's like a digital skeleton key, allowing attackers to unlock and manipulate databases, leading to breaches of confidential information, unauthorized modifications, and even disrupting application operations. SQL injection is not just a buzzword, it's a real and present danger to web security. So, how does SQL injection work? Let's break it down. At its core, SQL injection is a code injection technique. Attackers exploit vulnerabilities in web applications by injecting malicious SQL code into input fields or query parameters. This intrusion allows them to manipulate a database, potentially leading to data theft or unauthorized access. There are different types of SQL injection attacks, each with its unique approach. Classic SQL injection involves the attacker inserting malicious code that the database interprets as part of a SQL query. Blind SQL injection occurs when an attacker exploits a web application even without seeing the result of the injected query. Time-based SQL injection is a more sophisticated approach where the attacker sends a query to the database, which forces it to wait before responding, thus revealing valuable information about its structure. Understanding how SQL injection works is the first step to preventing it. Attackers have certain favorite spots for SQL injection. Let's explore these. Common attack vectors for SQL injection include web forms, URL parameters, and HTTP headers. These are all areas where user inputs are accepted and then processed by the web application's database. Web forms are an obvious target. They're everywhere, from login pages to search bars, and often directly interact with the database. An attacker can use these forms to insert malicious SQL code, which, if not properly handled, can be executed by the database. URL parameters can also be manipulated. These are the bits of information that follow a question mark in the URL. They're used to pass data to the server. By tweaking these parameters, an attacker can inject harmful SQL commands. And then there's HTTP headers. These carry information about the client browser, the requested page, the server, and more. Certain headers, like the user agent or cookie headers, can be exploited for SQL injection if the application includes their values in a SQL query. Now, let's consider the steps involved in exploiting these vulnerabilities. It typically starts with identifying a potential target, which could be any web application that interacts with a SQL database. The attacker will then probe the application for SQL injection vulnerabilities, often by using a technique called fuzzing. This involves sending a series of inputs designed to trigger an error that reveals a vulnerability. Once a vulnerability is found, the attacker will experiment with different SQL payloads to understand the structure of the underlying database. This is a critical step because it helps the attacker craft a SQL payload that can extract sensitive data or perform unauthorized actions. The final step is the actual exploitation. This could involve dumping the contents of the entire database, modifying data, or even gaining administrative access to the system. Knowing where to look for vulnerabilities can help in detecting and preventing SQL injection attacks. The consequences of SQL injection attacks can be devastating. Let's delve into this. SQL injection attacks can lead to severe data breaches, resulting in the loss of confidentiality for sensitive information. This could mean the exposure of personal customer data, confidential business information, or even the keys to your digital kingdom, your administrator credentials. Imagine the chaos that ensues. There's not only the immediate financial loss to rectify the breach, but also the potential for hefty fines due to non-compliance with data protection regulations. Then there's the damage to your organization's reputation. Once trust is lost, it's incredibly hard to regain. Take the infamous Heartland Payment Systems breach of 2009, for instance. Cybercriminals exploited SQL injection vulnerabilities, compromising over 130 million credit cards. This attack cost Heartland a staggering $12 million in settlements alone. The fallout from SQL injection attacks can be far-reaching, impacting an organization's reputation and bottom line. Prevention is better than cure. Let's discuss how to detect SQL injection attacks. The first step in prevention is detection. Organizations can detect SQL injection vulnerabilities using a combination of manual and automated testing techniques. Manual testing involves a thorough examination of an application's behavior in response to unexpected or malicious inputs. Automated testing, on the other hand, leverages software tools to scan web applications for common vulnerabilities, including SQL injection. But detection is not enough. It's crucial to implement preventative measures. Input validation is a fundamental technique that ensures only properly formatted data enters your system. Parameterized queries are another effective method that separates code from data, preventing an attacker from manipulating SQL queries. And let's not forget web application firewalls. These are your sentinels blocking malicious traffic and preventing exploitation of vulnerabilities. Remember, SQL injection attacks can cause severe damage, and while we can't eliminate all risks, we can certainly minimize them. Detection is the first line of defense against SQL injection attacks. Now that we know how to detect SQL injection, let's talk about how to prevent it. Mitigating SQL injection vulnerabilities is a multi-layered process, and it begins with secure coding practices. The first line of defense is input validation. Every piece of data that comes into your system from an external source should be treated as potentially dangerous. Validate it against a set of rules or a whitelist to ensure it's exactly what you expect. Another crucial practice is output encoding. This means converting potentially harmful characters into a safe format that the system can understand but won't execute. It's a bit like translating a foreign language into your own, but leaving out any offensive words. But even with these precautions, we can't guarantee that all harmful inputs will be caught. That's where prepared statements come in. These are SQL statements that are sent to the database ahead of time with placeholders for the data. When the data arrives, it's treated as just that, data, and not part of the SQL command. This prevents an attacker from injecting malicious SQL into your queries. Now you may be thinking, I've got a lot of code to write. And you're not wrong, but there are tools out there to help. Web application firewalls, or WAFs, can provide an additional layer of protection. They monitor HTTP traffic to and from your web application and can block suspicious activity. It's also worth investing in automated testing tools that can scan your code for SQL injection vulnerabilities. These can be a great way to catch issues before they make it into production. Of course, tools and technologies are only part of the equation. It's crucial to foster a security-conscious culture within your development teams. Regularly review and update your coding practices and provide ongoing training to keep everyone up to speed on the latest threats and mitigation strategies. Remember, SQL injection attacks can cause significant harm to your organization's reputation, not to mention the potential financial and legal repercussions. Proactive prevention is the key to safeguarding against SQL injection attacks. Let's wrap things up and recap the key points. We've taken a deep dive into the world of SQL injection attacks, a prevalent and potent threat to the security of web applications. These attacks exploit vulnerabilities through the injection of malicious SQL code, leading to unauthorized access, data theft, and potential damage to organizations. We've explored the different types of SQL injection attacks, such as classic blind and time-based SQL injection. Each of these exploits different aspects of a web application's defenses, but the end goal remains the same: unauthorized access to sensitive data. Common attack vectors include web forms, URL parameters, and HTTP headers, and the consequences of a successful attack can be catastrophic. Data breaches, loss of confidentiality, and reputational damage are all potential outcomes, as we've seen in numerous high-profile security breaches. But it's not all doom and gloom. We've also discussed strategies to detect SQL injection vulnerabilities, including both manual and automated testing techniques. Input validation, parameterized queries, and web application firewalls can play a pivotal role in preventing SQL injection attacks. Mitigation strategies include secure coding practices such as input validation, output encoding, and prepared statements. By adhering to these practices, organizations can significantly reduce the risk of exploitation. We've examined case studies that highlight the consequences of inadequate security measures and underscore the importance of proactive vulnerability management. Regulatory compliance, such as the Payment Card Industry Data Security Standard and the General Data Protection Regulation, also play a critical role in protecting sensitive data. Finally, we've emphasized the importance of security awareness and training. Developers, administrators, and users all need to understand the risks of SQL injection attacks and contribute to a security-conscious culture within their organizations. Remember, staying a step ahead of SQL injection attacks is crucial to ensure the security of your web applications. It's not just about fixing vulnerabilities, it's about preventing them in the first place. So, let's stay vigilant, let's stay informed, and let's stay secure.